Hi everyone, and welcome to today's webinar. I'm Michaela Lozano, and we'll be discussing simplifying your cloud-native development workflow with Kublr. Today's presenter is Oleg Chanukin, CTO at Kublr. If you have any questions, please post them in the chat, and we'll make sure to address them. Okay, let's get started.
Okay, yep. Thank you, Michaela. Thank you for the introduction, and welcome everyone. Thank you for joining this webinar today. We are going to talk, or I'm going to talk about CI/CD environment deployment using infrastructure, or actually everything as code approach. So we'll try to run sort of in an hour or so a full-blown CI/CD, automated CI/CD environment using Jenkins, Kubernetes, Kublr, and Nexus, the main tools in this demo. But before going there, so a couple of words of introduction. So I'm CTO at a company called Kublr. So we work on a product also called Kublr, intended to manage Kubernetes in enterprise environments. So Kublr is providing essentially control center for Kubernetes clusters running in different environments, in different clouds, or in the data centers, with centralized log collection, monitoring, identity management, access control, etc., etc. And as such, so what we see with our clients is that having tools to provision and operate Kubernetes is probably only half of the problem. Another half is going through this learning curve of how to work with Kubernetes, what to do with Kubernetes in general, how to build and run your applications on Kubernetes. So we run a series of webinars and in general tutorials that help our clients and, well, anyone, in fact, to learn Kubernetes faster. And this webinar is one of this series. So I will use Kublr here to provision Kubernetes cluster, but it is not really Kublr specific. So you can provision this Kubernetes cluster using other tools, whether it's your managed Kubernetes with your cloud provider, or self-hosted Kubernetes cluster, or kind or Minikube you are running on your virtual machine. So you can essentially repeat this demo more or less without changes on any Kubernetes cluster. And what we'll talk today about is, well, I'll touch Devops architecture in general, so main components of DevOps stack. We'll look at Kubernetes as an application management framework. We'll talk specifically about running CI/CD stacks with cloud-native environments and specifics of cloud-native environments related to CI/CD. And of course, we'll run this demo based on a GitHub project that we have on our account, Kublr DevOps Demo v2. So you can just use this GitHub account to run through the same demo by yourself. So this will serve as our everything as code example. And in fact, so this demo is designed to be used as a simple template, which you can build on when you are setting up your own CI/CD environment and auto-build projects. So without further ado, let's start. And the first thing I'll do before going through the presentation and talking about concepts, let me kick off a cluster creation, because infrastructure provisioning is usually the longest part of the process. It will take maybe around 10 minutes. And while our cluster is being provisioned, we'll talk about basic concept, and then we'll get back to our demo. So we'll just follow more or less steps in these projects. Again, discussing different concepts along the way. And the first step is to deploy a Kubernetes cluster. Let me open a cluster specification that we will use to do that. So I'm just going to use Kublr user interface to submit this cluster specification and to create this cluster. You can do that via API, of course, or if you are using other tools, you'll use different type of artifact to provision your cluster. So this step may be different depending on what kind of Kubernetes you are using. But whatever it is, it will result in a new Kubernetes cluster running either in the cloud or on your local machine. And you may notice that I have two other Kubernetes clusters running. So one of them is also an AWS cluster, just as this one I have just created, just running in a different region. And the other is in Azure. Well, demos can go sideways sometimes, so I just have this as my spare cluster in case anything goes wrong with this one, and I will use Azure cluster to compare essentially how different and where are the differences and where are the similarities when you use the same stack on top of different clouds. And we'll talk about that in a bit more details. So Kubernetes is a great equalizer in a sense. So Kubernetes may be your infrastructure abstraction, which allows you to forget to some degree about differences and in infrastructure providers and treat essentially different clouds and even data center on-premise environment as a single level field, your essentially cloud in your pocket in some sense, especially if you have Kubernetes management tools, and we'll talk about that as well. So let's first speak a little bit about general architecture of a DevOps stack. So, and whatever framework you are using, whatever project structure or process or dev tools, so there is somewhere an infrastructure in your picture. Even if you are running applications using serverless frameworks managed in the cloud, like Lambda in AWS or functions in Azure, somewhere there under the hood, there is virtual machines or physical machines, load balancers, network storage. So it is often useful to be mindful of that and remember that even in the best abstraction leak is possible, and there is infrastructure underneath. On top of that infrastructure, you use potentially multiple frameworks. Sometimes it's simple or it's more complicated. Those frameworks or runtime environments may be your container orchestrator, Kubernetes, Docker Swarm, Mesos, or your serverless framework, either it's a managed framework or framework like, again, serverless running on top of Kubernetes, or it may be a service mesh, app servers, whatever it is. It's a set of tools that are sort of in between your application and the infrastructure. In the real life production use, you always have a category of operations tools where you keep your logging, monitoring infrastructure, maybe provisioning tools, identity management, integration, etc., etc. And of course, there are development CI and CD tools like version control system, CI, continuous integration, continuous delivery, binary repositories. So all those are part of the picture. And in many cases, again, you may forget or not really, or to be able to not really have to manage some or most of them. Again, in the corner or edge case of fully managed environment, everything or almost everything out of this scheme runs as a managed service in the cloud. But sometimes you may be hosting the whole stack, and like when you're running on-prem and you don't have sort of ready-to-use solutions. And in any case, it makes sense to use a star as code approach, where you can formalize, or at least it's the best practice, to try to formalize as much as possible of that stack. So it's easier to recover, it's easier to create a backup and disaster recovery strategy with this approach, and it's generally more robust and essentially self-documenting. So when your infrastructure even is expressed in a formal way and ideally as a source code. So Kubernetes is a great enabler in that with that approach. So Kubernetes can combine capabilities and can host actually almost all of those tools. So at the first side, Kubernetes is your application operations framework, right? So you have Kubernetes, which is a container orchestration tool. So you use it to deploy and orchestrate containers that belong to your business application. But sort of extensive view of Kubernetes allows you to treat it again as this universal infrastructure abstraction on top of which you can run additionally your tools as well, like the same logging and monitoring, and your CI/CD tools can run on top of Kubernetes. And on the other hand, Kubernetes becomes this layer between your infrastructure and your applications, abstracting you from specific of this or that cloud provider or data center, etc., etc. And the fact that it provides API, it provides declarative tools to define your application structure. It makes it easier to implement this everything as code approach. A number of tools are available in each of these categories. So specifically for this demo, we'll use Kublr as an infrastructure provisioning and operation tools provider with logging and monitoring and ability to provision Kubernetes in Azure and AWS. Of course, we are using Kubernetes as our runtime environment and container orchestration. We'll use GitHub and Nexus and Jenkins as our CI/CD stack. And we'll look at an example of almost fully formalized CI/CD stack. So we will spend maybe 20 minutes setting up a cluster with all these tools that will automatically build our sample project. So let's check what's happening with our cluster. Yeah, our cluster is getting gradually up and running. So it is already have all the nodes provisioned, which are still initializing at the moment. So we'll give it a few more minutes. And let's look at the architecture of CI/CD process and CI/CD tools. So relatively middle complexity sort of architecture with main components that are almost always present in any CI/CD process is here. So we start with a source code, which is kept in source repository. Nowadays, it's more often than not a Git-based repository, GitLab, GitHub, Bitbucket, something like that. You have a CI tool or server, continuous integration server. Again, it may be a managed service like Circle CI, or it may be a hosted tool like Jenkins or a managed Jenkins instance. So there are a lot of options here. So CI tool watches changes in source repository and builds binary artifacts that are stored in a binary artifacts registry. And in Kubernetes world, the most important registry is Docker registry, so where Docker images are stored. And again, this registry may be a managed service like Docker Hub, or your own hosted registry based on Nexus or Artifactory, things like that. Often, if the process is mature enough, you also use continuous delivery tools. So continuous integration, while continuous integration can be used to automatically deploy a freshly built application binaries to development environment, if you want to essentially propagate those builds to QA production even environment automatically or semi-automatically, it often makes sense to look at continuous delivery tools. Spinnaker is a great example of a tool like that. And the difference from continuous integration is that continuous delivery allows you to implement more probably complex and more interactive process flows for application propagation between environment. So for example, you may include in your automated propagation flow a step which requires manual approval from operator or administrator after QA or manual QA testing stage is done in a staging environment. And this is usually done in those continuous delivery pipelines in a continuous delivery tool. So this picture shows some of the options available out there in the open source community for different components like Jenkins or Flux for CI, Nexus, Artifactory, or Docker Hub for registry, etc., etc. So in our case, we will implement a little bit more simplified scheme. So with a cluster, single Kubernetes cluster, which will both a CI/CD tools environment, a cluster which runs Jenkins and Nexus Docker registry, as well as a target environment. So this Jenkins will build and deploy our sample application into the same cluster, just in a different namespace. We will get sources from GitHub from the same project I showed. In addition to just this long description of what we are doing, so it includes this simple API project, which is automatically built into a Docker image with a simple web UI service. It includes 3 different cluster specifications for Kublr that can be used to deploy clusters with Devops tools embedded in this specification in different environments in 2 regions of AWS or in the East US region on Azure. And it includes some build automation scripts. And we'll talk about that for a little bit. So let's see how our cluster is, and looks like it's more or less healthy. So it started all the additional components. So one thing that we need to do manually, although it's also it can be automated, but there are still some edge things that often operators and administrators leave to manual configuration. So in this case, we need to configure a wildcard DNS record, which will point sort of certain DNS names at ingress load balancer for this cluster. So, and to do that, I will use Route 53 configuration. So I will need to first save a kubeconfig file for this cluster. So it will require I need a few seconds for that. Okay. Saving it. Okay, so I stored a kubeconfig file for this cluster in a kubeconfig file here, and now I should be able to use my kubectl. Let's check. Yes, I can see nodes of my cluster. There are 3 masters and 3 workers. Just to provide an example of a cluster which can be failover ready and reliable. And now let's go through the instructions and see how we can configure. So first of all, we need to check the load balancer assigned to an ingress controller in this cluster. Yeah, here it is, AC9E. So we should associate this load balancer with a DNS record here, AC9E. Here it is. So, and now any DNS request fitting this wildcard will be forwarded to this cluster, to this cluster's ingress controller. So applications running in this cluster can be exposed just by creating an ingress rule in that Kubernetes cluster. And here we can see that, yeah, it works already. So just pretty much arbitrary name in this subdomain forwards or sends us to a 404 page generated by ingress controller in that cluster. So let's see what are our next steps. So our next step is setting up Nexus Docker registry. Well, running in that cluster. Where does it come from? So normally Kubernetes clusters don't run Nexus and Jenkins. Well, for this specific demo, what happens? We decided to treat Nexus and Jenkins in this context as a part of our essentially system level. So they are deployed as Helm packages in these Kubernetes clusters, and those Helm packages definitions are embedded into the cluster specification. So this is Kublr's feature, so where you can essentially define a set of packages, additional Helm packages, as a part of your Kubernetes cluster, and it will be deployed again according to the values you provided there together with the cluster deployment. So we already have, and we can check it using Kubernetes dashboard. So we already have a DevOps namespace in this cluster, and in this DevOps namespace we have Nexus and Jenkins running already. And because I have just associated a valid DNS resolver with this cluster with ingress controller, and I have also Let's Encrypt integration configured in that cluster in this specification. So most probably Nexus and Jenkins running in these clusters have already been exposed and have valid certificates. So let's check it. Oops, no, not yet. So still working on certificate issuance. Let's see. Here we see there are secrets intended to store those certificates, but we don't have certificates issued yet. So sometimes it requires some time for the certificate manager running in this cluster to connect Let's Encrypt and get the certificate back. And we see that for one name registered there, at least we already get this certificate issued, but not for Jenkins and not for Nexus yet. So let's wait for a minute or two, and while we are waiting, so let's go through a few more slides. So in this specific case, this cluster was created in AWS in US East 1 region. What other elements of the cluster spec should we note here? So let's scroll to the beginning of this cluster specification. So, and we see that this cluster includes, well, first of all, description of the AWS location in which it's deployed. So it includes 3 zones. It includes some additional resources, in this case, EFS file system with mount targets in every zone of this cluster that we are provisioning. And we are using EFS exactly because it's multi-zone deployment. So EBS are zone local. So if you provision an EBS in zone A in AWS or in Azure, it works the same in Azure. You cannot mount that EBS to nodes running in zone B. So this will not be a true sort of reliable failover solution. So we are using a distributed file system which can be mounted in any zone. There are other ways to approach this and make multi-zone deployment truly reliable. We have master group definition, which is a little bit more complicated and longer than for a standard Kublr Kubernetes cluster, because it includes, as you can see, mixed instance policy definition. So, and because it uses mixed instance policy with on-demand percentage above base capacity 0, it means that it will use either T3 medium or T2 medium instances running on spot capacity in AWS, which is often 3 times less expensive than regular on-demand instances. And the same is true for nodes. We have a mixed instance policy with a set of instance types acceptable for this group running on spot instances. So which allows us to have 6 instance cluster, 3 masters, 3 workers, without breaking the bank, because they all run on spot instances, and at the same time without losing reliability, because Kublr and Kubernetes setup in AWS will make sure that even if instances are taken away, they will immediately restart in those zones where they are still available. And there are some customization related to the fact that we are using EFS as our main storage. So we are retargeting various components of Kublr, such as centralized monitoring and log collection, to store data on this EFS file system. Okay, let's see if our secrets were provisioned. Looks like there is some problem with that. Let's verify it. So for some reason, only one certificate was issued, and we still don't have valid certificates here. So it won't allow, and because Docker is picky about the way certificates are configured, so you have to make special effort and special configuration to let Docker work with self-signed certificates or with non-HTTP, non-HTTPS provisioned. I mean, Docker running over HTTP. So the rest of the demo will not work until we get those certificates issued. So, and that's the reason why we have pre-configured instances that already have all that running. So let's switch to Devops demo USS 2, where I already went through all of these steps and set up the configuration required to build this process, this project. And what that configuration is, let's see. So first of all, we have our Nexus server running there, and one of the settings that we configured in this Nexus server is ability to host anonymous, so Docker registries with anonymous access. So by default, when we create a hosted Docker registry in Nexus, you can only access this register after authenticating as a user registered in this Nexus. But to simplify the demo, we configured with anonymous access, and now this Docker registry can be used just as any other, just like Docker Hub, for example, without explicit login. Another setting that we needed to do relates to, or another set of configurations that we needed to do here relates to setting up Jenkins. So first of all, after Jenkins is first started, after the cluster is up in Kublr, it does not have permissions to do anything in that cluster. So essentially, Jenkins uses a default service account in the namespace it runs in, and this service account pretty much is powerless, so it doesn't have permissions to do anything in the cluster. But we are using Jenkins Kubernetes integration plugin here in this demo, which means that Jenkins needs to start pods to actually run build jobs. And to do that, it will need some permissions. So, and this is the first thing that we need to do after Jenkins is deployed, is to give Jenkins permissions to start pods in that cluster. And the rest of configuration is related to setting up Jenkins job that will build our project here. Our project is already configured as a pipeline as code. So we have this Jenkins file in the project which defines build steps. So as soon as this Jenkins file is provided to Jenkins server, Jenkins will know what to do with this project, how to build it. The only question is to tell Jenkins where to find it, and secondly, to essentially give Jenkins parameters that this build file will use to actually run the build. So you may notice here in this Jenkins file that it uses certain credentials, it's called in Jenkins, to get generic parameters like what cluster domain to use for deployment, what Docker registry address to use to publish the build artifact, and Docker registry credentials. So these parameters are registered in our case as credentials here in Jenkins, and in this GitHub project, when you are looking through README, you will find instructions on how to create those credentials either manually or using curl scripts and API in Jenkins. So, and the last step is to actually register the job which builds this project, and the job is registered as a multi-branch pipeline which takes the source code from our GitHub account, from our GitHub project, and that's it. So essentially Jenkins will watch the project as soon as this project is built or registered, the job is registered, and it will build every branch it finds in that project. So in this case, our project has two branches, main and feature blue, and it did build main branch successfully, and it deployed it, and it did build feature branch successfully. We can check the build log, for example, to see all the steps it went through, and it deployed it successfully using Helm package, which is also part of our project. So let's see it here. And again, it's very simple Helm package, which just creates one deployment, one ingress, one horizontal pod autoscaler, one service, and one service account for this simple application. And as a result of this build, we can check it in that cluster that we have set up already. So let's see. Every branch we have in our GitHub repository will result in a corresponding namespace. Like here, for example, we have feature blue namespace and we have main namespace with our simple API application deployed. And this simple API application have an ingress rule which exposes it on a URL in the same subdomain, and we can check how it looks like. So if we look at this application built from the main branch, we see that, well, it shows us some web UI. If we check the feature blue namespace, that's how we hit another application in the other namespace. Now you probably get why the feature was called like that. That's because under this branch we just changed the background. And if we want to see how it works when we edit something in the application, so let's go to the project. So let's check that nothing needs to be changed there. It's up to date with GitHub. Now we can edit something in the project. So we can create a branch called, let's call it red. Okay, we are on branch red, and we can change something in our application. So, for example, in the content, we want to invent the bicycle. We'll just change the background color to red. Okay, here's our changes. And as soon as we push this branch to GitHub server, let's see if it really appeared there. Yes, we now have the red branch there, and we should be able to see that Jenkins picks it up and builds. And at this point, we don't have sort of hooks configured for this project, so Jenkins will not get an immediate notification from GitHub, but it's configured to periodically check this project. So I would expect that within a minute it will notice that there is a new branch, and here it is. So we notice, we can see that it noticed that there is a red branch out there, and it started building it. And we can actually see sort of under the hood what happens. So if we go and check our DevOps namespace where Jenkins run, you remember that we saw two pods there before. There was Jenkins and Nexus pods. Now we see the third pod, which is actually a build job started by Jenkins to build this project. And we can watch how it works. We can see all the steps, and right now it's already on the step of, so it just finished building Docker image. It tagged it. It's going to push it, I suppose, to the Nexus repository, and then it deploys it into our cluster. And we see that the build was successful. We have our first build in this branch successfully finished, and we can check that our application was actually deployed into our cluster. And yes, it is. So we have our new namespace created automatically with named red, and we can check. Now imagine that we are playing the role of QA team, and we can verify that yes, background did change indeed. So to summarize what we did and what we were able to model on this simple example. So essentially we have a project where we formally described our environment together with infrastructure and system level components like Jenkins and Nexus. We have a project with a formal description, pipeline as a code description, Jenkins file, which fully defines Jenkins behavior required to build this project. We have So we have build scripts embedded in this case, in case of this project, into our Docker file. So essentially in this Docker file we have the first part which actually runs build scripts for this project, generates a binary artifact, an executable, which then becomes wrapped into a container or into a Docker image essentially, which will be then pushed by Jenkins file to a binary repository. As a part of the same project, we have a formal description of Kubernetes deployment model for this project. So Helm package, we have source codes for here, fully defines essentially how this application can be deployed into a Kubernetes cluster and allows you to vary different parameters of this application through values. Like we can increase replica counts, we can adjust version of the image that is getting deployed. We can provide different parameters for ingress rules, resources for this application, etc., etc., etc. Auto scaling, so everything is configurable through parameters of this Helm package. And again, Jenkins file brings all that together by embedding several stages, like checking out the source code, building a Docker image and pushing it to a Docker registry, and then deploying this Docker image using the Helm package to development environment. And the last, we sort of have semi-formal description of how this all comes together, how this specific project is registered in that specific DevOps environment with Jenkins and Nexus. So we have scripts that allow you to register a job which runs these Jenkins files and using parameters specified in credentials in this Jenkins deployment. So, and again, so these steps can be also automated. It's just a question of specific context and how much you want to automate those rarely done steps like registering a job in your build system. Altogether, it gives us sort of full description of our system and our application and our DevOps practices that are live and sort of self-correcting and self-documenting. So you can just pass source code to a different team and they will figure out how to restore the environment and how to run, how to set up this environment and how to modify the practices if necessary. So we went through essentially these several slides talking about that. And as a result, we have essentially everything as a code DevOps stack for our deployment. There are some things that need to be taken into account when you are implementing a system like that. So of course, this is a demo. It takes some shortcuts and this scripting essentially is one of those shortcuts. Another question that you will face looking at the system like that is whether you want to use monorepo, for example, where everything is in a single repository, where especially if you have multiple components and multiple microservices versus multiple repositories approach. They each have their pros and cons. Big question is managing dependencies. So how you define dependencies and which dependencies you want to embed into your project, like vendoring in Go project or including essentially Helm package dependencies, for example, into your source base versus relying on remote repositories that contain those dependencies. Making builds hermetic or fully repeatable is often a source of complexity in projects like that, and a number of other things, especially implementing dry principle, don't repeat yourself when you're developing build script. So a good practice is to make sure that your build scripts build on each other, essentially from layer to layer. So you want to have build scripts that will work on local environment for developers from the command line, so they can just type make build local, for example, and fully build your application locally. And then each next level, so for example, building Docker image, should use the same build scripts that are used for local builds. Jenkins pipeline should use the same build scripts that build Docker images, and therefore the same build scripts people use for local builds, etc., etc. So there are a number of things, again, that we didn't cover here, but I hope that at least it shows how provides you with the foundations and baseline to start building a system like that by yourself, or at least get better understanding of how systems like that can work. And having said that, I think we are ready for the questions.
Okay, thank you so much, Oleg, for answering those. And thank you, everyone, for joining today's webinar. Please feel free to reach out with questions or topic suggestions at the email provided, and we hope you can join us next time. Thank you, Oleg.